So in this video we will be learning about the instructions and instruction sequencing. So instruction is like some command that is given to the computer in the form of some statement which will be loaded in the memory. So a program itself will be treated as a sequence of instructions. So here the different operations that is being performed by the computer and that we have learned earlier is the data transfer between the memory and the processor registers. Then it performs the arithmetic and logic operations on the data, then program sequencing and control, then the I/O transfers. So we can start with learning about the transfer of data as well as performing the arithmetic and logic operations. So the instructions that helps these two tasks we can learn in this video. Okay, so before that we need to know some notations that will be used for representing the instructions. So there are some notation like register transfer notation and assembly language notation. Here register transfer notation, it is like giving some symbolic names to the locations, memory locations. Okay, which means that we will be giving some variable names like LOC, R04 in order to represent some registers. So some names will be given, and if we need to access any data from the memory means we need to access via these variables. Similar is the case with accessing the data from the registers also. We need to use some variables starting with R. So that is a form of register transfer notation in order to identify any location. So it makes use of some symbolic names, and in order to address or in order to retrieve the content of that location, then we need to place square bracket around the name of the location, which means that LOC, R1, R2 they are variables that is used to represent some location. If I need to access the content of that variable, then you need to enclose that variable within the square bracket. Okay, so this form of representation. One more thing is there, that is it will be having a left hand side and right hand side separated by an left arrow symbol. Okay, so this is a form of representing the register transfer notation. That is meaning of this statement. R1 arrow LOC means that the content from the location LOC is transferred to R1. Okay, so in the second example, that is R3 arrow R1 plus R2. So what does it mean? Content of R1 is added with content of R2 and the result will be stored to R3. Okay, so this is the representing a register transfer notation. Same thing you will be able to represent using another form of representation that is called as assembly language notation, where you will be having some opcodes, operation codes followed with the operands. So this represents the machine instruction. So this will be representing the machine instruction, and these instructions, if more than one instructions, they are written in a sequence and stored in memory and is being executed, then that is called as a program. Okay, then so R1 arrow LOC, this notation can be written in assembly language notation like move R1 comma LOC. Okay, so in this PPT, we are making use of this R1 as the that is the first operand will be treated as the destination operand, and the second one will be treated as the source operand. So this may not be followed in some other computers. Some computers, what they will be doing is, first operand will be taken as the source and the second operand will be taken as the destination. When you check with the Karl Hammerscher textbook also, it follows the format as if the first operand will be taken as the source and the second will be taken as the destination. Okay, so considering the next example, add R1, R2, R3. Here what the first operand will be taken as the destination. So R1 arrow R2 plus R3. Okay, so this is a form of representation that is being followed in this PPT. But it is not necessary that all computers they will be following the same format. It can take the other form also. So CPU organization, that is when you are writing some instruction, it will be loaded to the CPU for further processing, and that will be saved to the local registers inside the CPU, and execution will be done. So there are some organizations that is being followed, that is single accumulator organization, general register organization, and stack organization. Single accumulator organization means it makes use of the accumulator in order to store the result. If an operand is being fetched from the memory and it is not being stored inside the register, then it can be stored inside the accumulator in order to perform the further operations. And similar is the case with storing the result also. Result also, if a destination register is not being mentioned, target location is not being mentioned, then to the accumulator the result will be loaded and further it will be loaded to the memory. Second form of organization is like general register organization, in which registers are used to hold the operands, and making use of these registers, it reduces the memory traffic. Frequently, it is not necessary to access the data from the memory. Instead, if the local registers are being used, then it reduces the memory traffic. Okay, so register bookkeeping operations, that is informations will be held inside the register, and those registers information, whether the data is stored or not, those information attributes related to the registers also will be managed. Then stack organization, the operands and result, they are always stored in the stack. It makes use of the stack operations in order to store the operands and the result. So these are the organizations performed or followed in the CPU: single accumulator organization, general register organization, and stack organization. And while executing the instruction, while doing the different operations with respect to this instruction, it comes across different phases, and it forms a cycle that is called as the instruction cycle. So starting with fetching, decoding, reading the effective address, execution. These are the different phases of any instruction cycle. Fetching is like fetching any instruction from the memory, decoding the instruction, that is identifying the operation as well as the operands, then reading the effective address from memory in case of instruction having an indirect address. That is, if instead of value, address is given in the operand field, means from the address it needs to access the data. That is, in the concept of pointers, it will be used in order to access the data. So for that, the target address need to be computed in such cases. Okay. Normal addressing, if it is used, means the target address will be the address that is given in the operand field. But indirect address means extra computations also is required to get the effective address or the target address. Execution of the instruction is like identify the operands and then perform the required operation either by the ALU or the load and store operations. So this is related to the cycle, and so the instructions that is being given into this cycle, it will follow a format like it will be having some fields like opcode and operand field. So, 12 bits will be used to represent the operand address, and 3 bits will be used to represent the opcode field. Then last 1 bit it will be used to represent the addressing mode. So with the help of addressing mode only, you will be able to understand whether it is whether the operand is having the direct address or indirect address. All those things you will be able to understand based on this addressing mode. Okay, then so details regarding addressing mode also you will be learning in the next topic. So opcode operation to be performed, address field, memory address, mode field is like it is used to find the effective address, that is in which way the operand can be retrieved from the memory. And instruction formats, we are having some 4 instruction format in which 3 address instruction, 2 address instruction, and 1 address and 0 address instruction. So from the term itself, if there is 3 addresses to be fetched from the 3 operand fields, if it is there, means that it is 3 address instruction. So in such cases you have to access the data from the memory. So 3 operands is there. 2 address instruction is like you will be having 2 operands, and format is operation, destination, source. Okay, 2 operands will be there. And 1 address instruction is like a single operand will be there, and accumulator will be the second operand that will be considered implicitly. Okay, so here add B means what operation is performed, accumulator, result will be stored in accumulator, and the content of B will be added with the accumulator value, current accumulator value. So here in register transfer notation, this M is being used in order to represent the memory. So if you don't use it also, it is not a problem. Only thing is that variable it should be enclosed within the square bracket. So in this PPT, this M is being used everywhere. So you can just neglect that M. You can follow the format that is given in your textbook. In textbook, such M is not being given. Just enclose the variable inside the square bracket. Then push operation, it is used to push the content into the